Welcome to It's a Controls Problem, where we do precision guesswork based upon unreliable data given to us by those of questionable knowledge. I'm your host, Charles Johnson. All right. Well, welcome everyone to It's a Controls Problem. It's your host, Charles Johnson. I'm here always with the great Matthew Vanberg. Matthew, good evening.
Good evening.
And I'm here with a very special guest today. His name is Brian Vaughn, and he is the principal advisor for his own company, Technify. Brian, welcome to the show.
Thanks, Charles. Glad to be here.
Oh, you're welcome. And so, Brian, why don't you go ahead and explain what Technify is?
Technify is a consulting entity that is working on the relationship between buyers and providers of technology. Oftentimes, it's not so much about the technology, but the ability for people to communicate with each other and understanding what it is they're trying to accomplish and what their actual needs and pain points are. So I am focused on that relationship between the buyer and the technology, as well as the vendor itself.
Okay, great. So let's go ahead and start from the beginning here.
Sure.
What was your initial professional path, and was there a specific moment or experience that first piqued your interest in the built environment, or perhaps was there an intersection of technology and physical spaces for you?
Sure. I fell into this space, I think, which would be the answer a lot of people would offer when you talk to whomever in the smart building industry or controls industry. It's not like I was sitting here as a young child, like dreaming of the day that I'd be talking to people about digital building strategies. Fundamentally, I knew I was an electrical engineer at heart. My dad was an HVAC technician. Was trying a few different paths with my career and came across an architectural engineering firm that had a team focused on technology integration engineering. And it was a dedicated group that focused on writing specifications in Division 25 and creating specific controls, drawing sets, pulling out your networking and mechanical controls and lighting controls and other systems from the different divisions and bringing it into like an integrated solution. I really saw the value in that piece, and it was a quick learning experience as we went through all the different sections of a design and understood like how those pieces fit together and what the end result was trying to do. We were able to we were in a better position to be able to integrate those systems to deliver a better outcome for clients. We also got pulled into a lot of different directions around like metering and global building management systems and advising on a lot of different types of solutions. I probably walked like 2,500 or 3,000 different buildings within a few years. So it was a very quick entry into the space, and I was kind of hooked from there. From there, I helped deliver some analytics platforms to facility management providers. I've worked on product side with a large corporation. I've also done advisory with a lot of different FM clients as well, and ran a global consulting team up until recently. And over the period of time, I've been able to expand my understanding and knowledge about the built environment and the different systems in there. They all fascinate me. I love learning about each different, like how the nuances of, parking technology, for example, something that somebody might think is very boring. It's most often somebody's first and last experience with the facility. So it's important what that user experience is like, and understanding the different personas and who's having to interface with that product is very interesting. All right. So it's a very fun space where you get to go inside the inner workings of many buildings and facilities and historical monuments, and you never know where you're going to end up in this industry. So that part, it keeps me going, it keeps me exciting. It's always a good place to continually learn about different people and what they do to help make the built environment exist. And I guess finally, like, it's the spaces that people live and work in. They spend their life in it. So to me, that's kind of what drives it forward.
I think that's really, I think it's a very, I think it's really interesting because, you know, being able to get into different systems, like you mentioned, parking and whatnot, right? Like some of those things, we don't necessarily get the chance to experience on our own. So you get these unique perspectives, and at times you have to learn some of that additional thing that maybe someone in my in my particular on my particular side uh, doesn't really get we don't really get the option to do that, but on your side, you're able to actually see how it can be integrated, and you do some deeper dives into that. One of the most interesting buildings I ever had to work in was in Lanham, Maryland. I think it's in Lanham, Maryland, and it was actually the an archive. I don't remember the name of the building, but it was an archive museum, and it actually maintained the clothes where in which Abraham Lincoln was actually the attempted assassination, which I thought was really cool. And there were some unique artifacts from the U.S. history still in there, and so maintaining like the humidity and stuff like that. It was very fun to kind of get around and see what's going on there. But as you have moved into the world of building systems, obviously you've encountered a lot of traditional approaches as well. So what were some of the, initial frustrations or inefficiencies that you observed that made you think there has to be a better way?
I think there's still two key things that persist that drive me crazy. One is the design process and the approach on how we're delivering an integrated solution to a construction or an improvement or tenant improvement project or anything along those lines. That part we can get into. And then the other piece is the operation side. I still feel that we're barely scratching the surface of what we can do from an operations perspective using the sensors and technology and different systems that we're able to deliver within a building, which then feeds back into that whole design process and value engineering component and understanding the total lifecycle costs of what some of these opportunities are. So those are the two things that still fascinate me that we're struggling to advance in the last 17 years.
So what do you think is so when you mentioned the design process, what do you think is antiquated about it now, and what kind of forward thinking does that needs to happen and to continue to move it into the progression in which you are envisioning?
So one of the things that I felt hasn't changed a lot, and I have to be honest in the fact that I haven't worked at an engineering firm in a number of years, so things I hope things have improved a bit. But when we were typically working on projects, it was an afterthought. For example, we were brought in typically late in the design process, 90%, 100%, and looked at the designs that were being done and the specifications that were being done by the disciplines. And then we had to like create a control strategy and create a control set of drawings and solutions off of that.
So do you prefer design build over plan and spec because maybe you might feel that you get more of an input up front in the design build versus a plan and spec job?
Well, it's not I mean, I'm not even going to touch on the fact that like how buyers or developers actually build a building that may or may not be what the owner wants. Like that's not something I want to try to get into in this conversation, but the idea that um, thinking about the technology and use cases and things at the forefront, similar to understanding like what do you want your building to look like, what do you want to use your building for, how are you going to program the spaces. Like we need to talk about that user experience, the branding that you want associated with that building as well, or that project. We have to understand like how do you want people to experience that space and really get into like what it is that you think will move the needle on
Okay.
the part that I see and I still feel happens readily is we we go ahead and like the mechanical engineers go off and do their thing, the electrical engineers go off and do their thing. You have your networking designers doing their own thing, telecom, whatever, right? And at the end of the day, we have to tie those things together. And we were brought in typically like 90% and said, all right, fit these things into a control specifications, do a drawing, and we would go through those designs, and we'd find that they rarely matched. They rarely fit together. So we would have to go back and mark up all the drawings, mark up all the specifications, give that back to those disciplines who were already maxed out on hours and time, and then we would be the bad guys for screwing up a project. And it was kind of like screwed up from the beginning. So it's just, to me, it's like getting into the habit and getting, like we work with architects. I've from our Boston SMOD chapter of Building Intelligence Group, we've really been trying to focus on getting more architects in the conversation, because they're typically the ones that are doing the project management. They're typically the ones that are overseeing that whole design process. Increasing the awareness, increasing the understanding of like what the opportunities are from a technology perspective for facility operations, for the construction cycle, and everything else, like helps set the stage to make sure that all the various disciplines have the same marching orders, have the same end goal that they're working towards.
So, one thing that is interesting, is the term, especially when you're looking at specifications, you hear building automation system, and then obviously we know that that's widely used. But for many people outside of the industry, that just often equates to HVAC control, which you and I know that it's not. It's significantly more than that. So, how would you explain the broader scope of BAS, and why do you think maybe the perception of building automation is just HVAC control versus?
Good question. And I would say, even in our industry, if I say BAS or building automation system or building management system, whatever you want to use, 95% of the people I'm talking to assume I'm talking about HVAC controls. Like, I don't think there is any awareness of the ability or the fact that it should be the broader scope of work within the entire building that can be encompassed within a BAS, right? Like I can't imagine that anybody would hear the term BAS and think outside of mechanical systems.
Sure, but the thing is, like, especially Niagara being one of the most ubiquitous systems out there, right? There are like 1.5 million instances of it out there.
Yeah.
The thing is that, yeah, like, especially for a lot of people, that they just deal with one specific portion of it. But people can tie in, not just the HVAC side, but lighting, elevator control, shading, um, EV charging stations, things that may not necessarily be in what I would consider the scope of a controls contractor. But now we have this integration platform. Um, Now that we have this integration platform, people want to bring more into it. So, I don't, I absolutely agree that a lot of people will always assume that it's just the mechanical portion. But it really can be significantly more.
Yeah.
I think it's a matter of trying to re-educate even vendors, like, or controls contractors, to often understand that it's more than just what they're doing, especially since you mentioned Division 25, right?
Right.
Like, Division 25 is one of those, and before it was Division 25, it was 15. Um, and I don't know what Division 15 is now, but I think now everything just goes to 25. But um, but the fact is, like, even Division 25 references Division 27 or 28 or 14 or some other ones. So now all of a sudden, they need to be able to look and, like, okay, well, now they want us to integrate all this other
Yeah.
equipment here beforehand. So I think that people need to I do think people need to broaden their horizon, but it is very interesting to see. I
Sure.
just want to know what you thought about it.
Yeah. No. Like the ability for what a Niagara system can do, for example, is barely even, like people barely scratch the surface of what's possible. I mean, like it's able to provide your access controls, it's able to do lighting controls, it's able to do a lot of those things natively within the platform itself. But I would argue just because of the master spec and the way general contractors put stuff out to bid, you're not going to find your mechanical controls contractor doing the lighting controls program. Like you're not going to go out and find a BAS contractor that's going to do the automation, like that would write or provide controllers across all the different types of systems or capabilities in there. You're still going to find like a lighting control system in Division 26. You're still going to find HVAC controls in 23. And then ideally, like 25 is defining like how we're going to be pulling these various systems and solutions together. But like there's still room for improvement on that. It's just odd, like I think Siemens has room control capabilities or focuses on that, as well as I know Lloyd has been pushing this for a number of years. Just like you have one controller that does shades, lights, temperature control, like there's no reason why we can't do that. It's just the way that everything's procured. It would really confuse a general contractor. So we're still kind of stuck in that antiquated mindset.
Do you think potentially it has to deal with how people define a solution? Um, because like, some people will say, "Oh, well, we're going to provide a whole solution," but at least in my opinion, I feel that their solution is just one product rather
Mhm.
than a variety of products to bring everything together.
There's a couple things, in my opinion, that are factoring into that. One is obviously the procurement channel for these systems, right? Like Distech and Enlight fall under the same Acuity brand, but like your Distech controls contractor isn't going to be able to procure Enlight controls, even though they all can integrate into their Eclipse product. It's a procurement thing, right? Uh, and then the other part that I see factoring into this too is there's some confusion as well when around terminology. Like I think master systems integrator is a term that is getting more established as somebody who is going to provide that overall solution, the integration of the different systems that are within a facility and delivering that overall product. There's people that are coming into that position from two different sides. One, typically your HVAC controls contractor that is upskilling with Niagara or other integration platforms to deliver that overall solution. And then you have your consultants that are realizing that there's an opportunity for them to provide more value by actually doing the integration as well. So they're upskilling them as themselves as well to be able to do the actual programming and integrations of these different systems and deliver an outcome. And I think you get two different flavors of solutions from the two different sides of that spectrum.
Yeah, I'll go with that. It's a good way to think about it. And I agree that sometimes it's hard. Like you mentioned Acuity, like having all the brands there, and then trying to get to like trying to get everything even from that particular company is definitely difficult for people for sure. And you're right about being able to like integrate. So yeah, I think that's a really good point where it's just a matter of availability to people. And you did mention, master system integrator. I'm not sure how many people really understand what the role of a master systems integrator is. So, can you say in your own words what you think a master system integrator is?
Of course, my opinion on what this term means is what I was alluding to earlier, where the master system integrator is responsible for delivering a final outcome, a use case, a scenario that is leveraging inputs and integrations across different solutions. So similar to how you would write a sequence of operations for a VAV box or an air handling unit that's taking different sensor inputs and driving different outputs on actuators or fans or drives. Likewise, like your master systems integrator is taking more macro level information and data points from those different systems and making sure that those are coming together to deliver different outcomes, whether that might be delivering an outcome through a lighting control solution or an elevator control or whatever. It's making sure the data is coming in, it's being processed the way it needs to be processed, the use case is being met, and the outcomes are being distributed into the proper systems. Ideally, to me, that's what a master systems integrator is. They're the ones that actually are making the systems work together, right? Networking them, making sure that the ontologies are correct, making sure that the IP addresses are correct, making sure that the network is properly configured. They're responsible for the end product of the integrated solution. I think there's different nuances to this. Some people see master systems like integrators more, or like the MSI, more as a consultant, somebody who's just overseeing and providing direction. Others see that person more as your standard controls contractor, which I think historically would fall under the systems integration or the SI terminology. So like people might say your lighting controls contractor, your HVAC controls contractor would be an SI, and then whoever's doing that more holistic solution would be your MSI.
Yes, I love the fact that you used the term holistic there as well, because that really is, I think, a very, I think it's a very great word that would embody the master system integrator there. So I agree with everything that you said about
And
it. But
if you don't mind, I'll throw out something else too. Like
sure.
there's the term master systems planner, an MSP, that I've seen used. I don't hate that one either. And to me, that kind of opens the door to the concept of who's the consultant, who's like the digital building consultant or the trusted advisor for the architect or the owner or the operator that's trying to orchestrate or design or deliver this solution, right? So they're kind of they're the architect, they're kind of the consultant, they're understanding like what the different systems are and what they can do together. They can help define what that product is, and the MSI can actually be the one that's the brains behind it and deliver those solutions.
Yeah. No. Absolutely. I agree completely. I don't know if I have anything else to add to that. I think that was very well spoken and very well thought out. So one thing that I find now that it's currently a hot topic right now, and I've seen it literally 6 times this week, and actually quite a few things on LinkedIn about it is fault detection.
Okay.
So we know that some of the we know that these capabilities exist, but we don't always see them, kind of like baked into controllers at the edge. So, from your perspective, what are the primary barriers preventing this seamless integration, and what needs to happen to accelerate that?
I've enjoyed digging into this with you because I feel that you guys might have a better perspective or some insights that I don't really fully understand either. I feel at some point, and correct me if I'm wrong, I feel at some point along the way we've not embraced application specific programs or controllers as much as we could. I believe that is partly what puts us in a position where we don't have FDD embedded at the edge or within the controller. I do think that there's really no reason we can't have fault detection diagnostics running in your air handling unit or your VAV or your chiller plant. It's a matter of when we're writing custom programs or if we're delivering specific built up air handling units, how do you create analytics that are able to scale or be embedded into a controller as part of its firmware or operating system to like provide those alerts or notifications that go beyond just a user configured alarm.
So, for the audience out there who is not really familiar with the term fault detection, and I'll get back to the application specific stuff here in a moment. Can you elaborate for our guests or our audience what fault detection is?
Sure. And this is, again, people might have different opinions on this, and that's part of the consultant's opportunities to help define these for clients. Ideally, fault detection is using historical trend data to flag opportunities or situations in which equipment isn't performing as intended. Looking at having the ability, imagine your facilities operators looking at a controls graphic for your air handling unit 24/7 and being able to associate where your discharge air temperature should be compared to what it actually is all the time, and then flagging those instances in which it's not doing what it should be, right? So I would say fundamentally using trend data to create more intelligent alarms or indications and insights into what's not performing correctly.
Yeah, I think that's a good that is a good definition. I think it's I think with some people when it comes to application specific controllers, I think it's a matter of eh, I think people want things that can be configurable, but then all of a sudden
Mhm.
they want customizable at the same time. And
Yeah.
in my opinion, you can't have both, right? Like you either have fully customizable or you have a configurable. And some people kind of want the best of both worlds, and in my opinion, I'm like, well, then you need to kind of build part of that solution. Now, vendors can encapsulate a whole, a wide array of things, but I think in some instances it's a matter of like, you know, if we are going, if a manufacturer is going to do fault detection and build that into their application, um, it's like, okay, well, I think then from a controller perspective, like, okay, cool. Well, how many histories or how many trend logs do I want in this specific controller? Can the controller support, those kind of trend logs? And now while obviously, other systems that integrate those controllers have the ability to do that as well. I think that in some instances, having vendors I think it would take some redesign in some vendors, not all, but some, based upon what I know about specifications of controllers. I think in some cases they're going to definitely have to beef it up. And I think when it comes to like analytics, one thing that I do find a lot of people don't really understand, the analytics from a Niagara perspective, and even implement that. So people use like SkySpark,
Mhm.
um, and a few others. Like I remember when many years ago, man, this is probably like 13 years ago now. I was working with a controls contractor, and they had a very unique vision. They were doing a lot of fault detection before it was ever really a thing. Like
Yeah.
so what they would do is and it was as more of a service to their to their customers, where like current switches they didn't use any for statuses. They always used current transducers, and so they could do roll up over a 5 minute or 15-minute interval for amp draw. So like based upon a period of time, they can monthly give their customers a report, and then even compare them from month to month and then year to year. Like, hey, look, your VFD was functioning in here, but now we see that the performance of this VFD isn't as strong as it used to be. Now maybe it's time to look into replacing some of that equipment.
Mhm.
um, and I think that if certain things were made, I think easier from the contractor side to implement, I think analytics, like unless you're familiar with like SkySpark, I think like Niagara Analytics does have a higher learning curve for people.
Yeah.
And I think it's one of the big things that actually prevent people from using it more and more. Um, and I think that, we as the experts probably need to implement that better, um, to make it easier for the customer to use without them having to reinvent.
Right. And the more that we can standardize that program or the analytic, like I think when I look at FTD, I see two different approaches. You have your, what I'll say, like more of a model based analytic where it's like, this is how an air handling unit should operate. Not how this air handling unit should operate, but this is what should happen when you're commanding uh, your chilled water valve open. This is what should happen, right? And then in that model is also multiple ways of defining a, is the air handling unit on or off, right? Like, because some people have a fan status that they'll be able to read from. Other people might be looking at schedule. There's multiple ways of determining if an air handling unit is supposed to be running or not. And you'll have some of these more model based approaches that can be applied to a broader array of equipment that will look at multiple different data points to make that determination. So there's an actual analytic itself that is saying the unit is running and should be running, right? And once you've determined the unit is running, it's like, is it in cooling mode or heating mode? There might be different ways of determining that. So the analytic is written to be able to look at the various data points within any controller and to make those determinations and look at, what are my different data points to determine, like, what's my air temperature, right? Like at the return, at the discharge, et cetera, right? There's a variety of different ways that people might program or configure those things. And the more you can write the analytics so it can accommodate different things, the more standardized you can deploy that same analytic. Where the other side with, like, oftentimes with SkySpark, you're writing it more specifically for that piece of equipment. So you have a fan status, or like you have a specific mixed air temperature point, a discharge air temperature point, et cetera, and you're writing the analytics specific for that equipment. So you have to write it over and over and over again, right? It's harder to scale. It's harder to manage the analytic and things of that nature. But I think that kind of falls into that whole custom program conversation versus application specific thing that people have just gotten used to writing their own programs or configuring their own solutions. So it's harder to write that model approach, right? You have to take into a lot more considerations and thought. It's harder to write it, but once you write it, it's easier to control and scale it up. So that's kind of where I see two approaches for the FTD side. I do love that you brought up the current transducer rather than a current switch, because that was always like one of my early things that I was trying to push. Anytime I found a spec for a current switch, I tried to throw a current transducer in there and hope nobody saw that I changed it.
Mm-hmm.
It's like
Yeah.
it's like a couple extra bucks, right? Like,
Yep.
but it makes such a huge difference in terms of like energy management, in terms of like the whole preventative maintenance like the opportunity for doing like preventative maintenance with analytics. It opened the door so much. But like, when we get into the operation side, if nobody's looking at the information, what's the point of putting it in there?
Yep.
And operation side, like, they're so used to not having the data in front of them, they go out and they get it themselves, like with their own sensors or probes or clamp on CTs or whatever.
Yep.
We need to get the operations side involved in the design phase as well. We need to get the operations side thinking more about, how would I do this differently if I had this information? What can I take off my clipboard for things that I'm checking on a daily basis? How do I get out of having to do a tour of my building automation system every morning when I show up? Like, what are those things that I can be presented that I don't have to do this work? And I can trust that when an alert comes in, it means I have to do or take an action, right? Like, that's been my other challenge working with the FM side, is just like getting people into a room to like rethink, like, what does good look like? What can I do differently? How do I change my day-to-day process and procedure? And once we define that, then we can define the technologies, the data points, the analytics, et cetera, to be able to deliver that piece of information to allow them to change their workflow. And that can factor into, why are we not value engineering out the current transducer, right?
Right. Yeah. I think that's it's a good way to look at it. Do you think that part of it also comes with, how sequences are written? So, like, for example, um, you know, the way when I don't do many programming jobs anymore. When professional services, kind of need some help, I kind of step in. And so, like, for example, we'll just talk about, we'll continue with the air handler approach.
Sure.
And so let's say this is an air handler that just has a space temp. And so the sequence of operations says, when the space temp drops below the cooling set point, or rises above the cooling set point, we're going to open the valve to maintain space temperature set point, right? So at that point, someone can literally take a look at the sequence and say, okay, well, I'm going to modulate. I'm going to take, I'm going to take the space temp. I'm going to put that into a pit loop, and I'm going to use that to control my chill water valve. Or the way that I do it is, and I always do it this way because I still get the same result, it just doesn't say it in the sequence, is that I actually will just use the temperature and my set points as more of like a thermostatic operation. So if I'm above the cooling set point, I enable the cooling, and when I'm below the heating set point, I enable the heating. And then I actually allow the air handler to maintain discharge air temperature instead. And that way, especially from a from a cooling coil perspective, I always want to draw moisture away from the coil. And so like I think that it's some of those things that aren't necessarily laid out in a sequence of operation, that I think that if engineers wrote the sequence of operation the same way every single time, I think that it would take out a lot of the guesswork from the controls contractor of what they think the best way to control that is. Like, oh, okay, well, I'm maintaining space temp, but I'm using the discharge air temperature. And when I'm not in the cooling mode, because I'm below the cooling set point, I don't need to worry about maintaining discharge. And so, like, I think, like, in certain cases like that, because it's not always laid, spelled out
Yeah.
that way, people program it whichever way they want, which I think goes to more of your point on an application specific controller. It always works the exact same way regardless. It doesn't matter, right? Because however the system, however they designed it, is however they designed it. So I think that at that point, if you have the same set of criteria from controller to controller to controller, then I think that the analytics get easier to build because, well, it's already there. So you don't need to, like, you just have to build the analytic once and then just duplicate it a bunch of times.
Right. Yeah, I tend to agree, and like that was one of the other things that we would look at a lot too, was just how was that sequence written? Was it actually written for that piece of equipment? I hope.
Mhm.
Um, and like what's the intermediate steps between like if you're trying to reset your static pressure based on damper position on your VAV boxes, there's a lot of different steps in terms of like how you can take that approach. You can segment that out, looking at, resetting your CFM set point based on the static pressure. And then you can have your drive in a PID loop to, maintain the CFM. You can try to maintain your static. Like there's just a lot of different approaches to it. But like, I feel people, like you're saying, like reinvent the wheel every time. My favorite
Ye-
though, however, is the disconnect between the designer and the actual operator. I feel you'll see a lot of things that are just generic set points, like everything is always 55 degrees, right?
Right.
And then the operator, but everything's adjustable, right? Because the mechanical engineer can do more detailed engineering calculations to determine like what would be the right set point. Oftentimes they don't have time budgeted for this because, as with everything else in the construction process, it's all low cost bid or theoretically low cost bid, and everybody's squeezed on time and hours and costs, etc. Um, so they pick the standard temperature and say adjustable because, in their opinion, the operator is going to do whatever the operator wants to do.
Right.
And then the operator might be looking at this as like, well, the engineer said I have to maintain 55 degrees. And they're not thinking like, and they think the engineer did some calculation to determine like what the actual set point should be, when in fact he was just using rule of thumb and what a standard number should look like because he's assuming the operator is not going to really listen to what he told him to do anyway.
You know, do you think then that this is a do you think this is a feather in the cap of ASHRAE Guideline 36, where the more that engineers push ASHRAE Guideline 36, there's already a preset determined of sequences of operations in which it needs to apply, and so that takes the guesswork of how to control things, especially if it's just all one guideline.
So I don't know ASHRAE 36 to be
Okay.
honest,
Okay.
but based on what you're saying, I would say yes, it should. Like
So
any opportunity we can standardize this, like the whole idea that buildings are snowflakes drives me crazy.
right.
Like we're always like we're either trying to add heat or remove heat from a building, or we're trying to light a building, or we're trying to darken a building. Like we still have to work within the laws of physics and thermodynamics, right? Like nothing is able to do anything outside of those things that I'm aware of. Why do we have to like keep arguing over what's the right sequence to modulate a chilled water valve?
Sure. I absolutely, I agree with that. I tell you what, I'll send you the white paper on ASHRAE Guideline 36 if you're interested.
Sure.
Um, you know, you're seeing more of a push for it, whereas like companies like Automated Logic, they've actually been doing it for years. One of the key principles of ASHRAE Guideline 36 is like, so you're talking about static pressure reset based upon VAV damage, right?
Yeah.
So, well, now it's actually considered pressure requests, and there's a specific guideline of what is considered a pressure request, and then the number of pressure requests that you have, that will then start to do the trim and respond program for you. And so a lot of it has been predicated upon that. And so I think that for a true standardization, then I think the engineers need to. I think engineers probably need to then start looking more about that. And I'll tell you, I've not been I've not been a big fan of ASHRAE Guideline 36, but actually talking to you more has now made me rethink about what I think about ASHRAE Guideline 36, and I think there is now a stronger case for that, just um, because of the problem. I wouldn't call them problems, but because of the ways of thinking that people have continued to do over the entire course of the building automation history. Um, I think there's actually more of a proponent now for it than anything else. So actually, I thank you for that, because I've been waiting for someone to like, how you see the meme where the guy's sitting there with like a coffee cup, like with a coffee mug or whatever. He's like in an open park and he's got a
Oh,
table. Yeah,
in my mind.
yeah, yeah, yeah. Change my mind. Yep.
I wrote one. I put one out yesterday on LinkedIn about. I literally photoshopped myself, my head on for somebody, for that guy sitting in the park, um, with a comment. We won't get into it, but like I want, like when we talk about the software tools for operations to be more effective or efficient, like clients typically provide that solution for their FM outsourced providers to like to be more efficient providers of facility management. It drives me crazy. It's like, no, like have the facility management teams like pick the tools and the software and the analytics and things like that. They need to define like how they're going to operate more efficiently and how they're going to deliver a better maintained building for less money and provide better outcomes for the occupants. Like if it's their responsibility to do that, like they should be the ones defining what does that change management process look like, so they can pick the right tools and solutions and invest in those tools and solutions to make that happen, rather than the client providing it to them and then trying to like force them to use it. So that was something I kicked off yesterday. I was trying to get into an argument with people on using that meme. Sorry.
No, it's okay.
I can never say meme or mem, right? But whatever, not important.
Well, mem in French means self. So yeah, I can see it. Yeah, me. Yeah.
So on your ASHRAE 36 comment, like obviously if they're defining good sequences or standards, great, right? I think that comes, that's somebody to defend yes or no on. But I think the part where getting into the application specific piece, I'd like to see the scenario in which the edge infrastructure comes with factory controls. Like the box comes with a controller from the factory, the air handling unit comes from the factory with a controller on it. Like, why do we have to put custom controls on these things? Like theoretically, the guy who built the thing should know how best to operate the piece of equipment. If we're getting into that position, we can enable different outcomes and optimizations by using those enterprise platforms like Niagara, where we can write custom codes or sequences or scenarios for a specific application or building that might be looking at broader data points like for weather forecasts or the dirtiness of the grid at any point in time to factor in different modes of operation and then feed data back to those application specific controls to deliver a different outcome at that piece of equipment itself, right? Whether it's just manipulating a set point or configure like a variable within the controller itself, or if the controller is able to accept global inputs to change its operating profile, like even better. But ideally, it's like the more that we can standardize what each edge component is doing, we can orchestrate different demand response or space utilization or comfort or whatever the case may be. We can orchestrate those opportunities like higher up on that architecture without having to custom program or change what's happening in the individual controllers.
Well, you definitely alluded to it earlier, and I think it's actually a good segue here. Yeah, I think that a lot more equipment manufacturers should have the edge controllers there,
Mhm.
and without providing, without the need to provide, a lot of custom sequences of operations. And so, obviously, I know some controls contractors are going to feel some way about that comment, um, but I think what comes down to it there at that point is cost, right? Because you were talking about from a plan and spec perspective where you need to go with the least, with the most cost effective um, solution would be, and sometimes that's not a solution. And I think that and I think that kind of thinking can be kind of detrimental in the overall progression of where people want to go. I think what I find a lot of the times is people want to start using these buzzwords and whatnot, but they really don't understand what it means or they don't want to they don't want to understand the effort that it takes to actually get there to truly, you know, it, to truly talk about it. I was, in a discussion about what an open system is. And I'm like, well, there really isn't an open system. And I think that, well, I said pneumatics at first, and the guy's like,
Yeah.
okay, well, that's old hat. I'm like, well, but it is open though. But I think for people to truly embrace, things at the edge like that as well. I think they don't really understand what it's going to take. More to the point, I had to do a job recently where, not really recently, several months ago, where there was an Aon rep, and they also had Semco units. And so someone to me said, "Hey, you need to program these Semco units." I'm like, no, oh, I don't." I'm like, "They come with ALC controls, and so why am I?" I'm like, "You just integrate them." They're like, "Well, these didn't come with ALC controls." I'm like, "What are you talking about?" Like, they always come with ALC controls. I'm like, "No, they got V." They're like, "No, they got VE'd out." I'm like, "Why would you VE out something like that?" And these were like ERUs with heat wheels, and they had the ability to do jogging
Yeah.
they had this entire sequence of operation that the controller would already do,
Yeah.
and now I had to build a custom solution just to do something that now probably they paid more money for
Yeah.
than actually paying the money to put it on the controller specifically. I
Yeah.
think in I think in some cases that you building that custom solution is significantly more expensive than just having the solution that you needed on there in the first place.
Yeah. I I mean that reminds me of a conversation I had a number of years ago where a client, a large automotive client, had an MSI or an energy management company that was they hired to do all their controls and for all their facilities and stuff. And we were just a lighting controls person, and they're like, we don't want your controls, we just want your lighting fixtures to be wirelessly controlled by our platform. And so they kept pushing. They wouldn't buy the controls. They wouldn't buy the controls. They wouldn't buy the light fixtures. And obviously, it's all about selling light fixtures. No, like the lighting manufacturer doesn't care about the controls. We want to sell light fixtures. So they were finally sitting in a meeting where the MSI, for the client and us were sitting at a table having the conversation, trying to figure out how to solve this for the client. And like we're like, the problem is, for you guys to do this, like you would then have to write the daylight harvesting strategy. You'd have to write the occupancy control strategy. You'd have to define like what the timeout is, like for the different aux sensors and different lights. Like what happens when a switch is pressed? Like you have to configure auto on, auto off. You have to configure manual on, auto off scenarios. Like, do you MSI want to write all those programs? And I'm like, no. We don't want to
Right.
do that. It's like, well, that comes standard in the controllers that are in the fixtures. Like if we just make them wirelessly, like remote controlled lights, you have to do all that stuff. So,
Yeah.
like that to me, it's like that's a whole application specific thing, right? Like the manufacturer, the system that has to operate locally can be predefined, and like there's really not much of a scenario once you have to change it.
Do you think that this is when we're talking about the evolution of smart buildings? Do you see this as the most significant blind spot or the area where the industry is still missing the mark?
In some ways, yes, because I think the part that it creates is there isn't a demand for interoperability. So if there's no demand for the interoperability, the market's not going to provide it. And what I'm trying to say there is like if the like we're used to from a consumer goods perspective for our computers like USB and Windows and Mac, like it's just we've accepted that those are the default standards on how everything's going to interact. And if we hadn't decided on that, we'd be in a whole different world today. And at some point, like the building automation system industry has to decide on an operating system or two or three and a standard way of systems talking to each other. And people might say like, well, that's BACnet. Well, is it? Like, I don't know if I
Yeah.
can have, I don't know if I can have, trained VAV box controllers talking to a ALC air handling unit, sharing schedules and a bunch of different data points without really having to put a lot of work into configuring those different points together to make them communicate.
Well, so actually, that's a really interesting thing. What if? So I did see someone when mentioning open systems, they're like, oh well, BACNet's the way to go, and in my head, I was gonna bite back. I'm like, well, should it be like couldn't it just be like MQTT or the
Yeah.
REST API or something
Yeah.
else that someone else wants to do? But what if, let's say, and I think this actually then comes back like on the BACnet committee itself, right? So like obviously you have the different types of controllers, right? Building, the building backend controllers, applications controllers, et cetera, et cetera. But what if, and this actually goes in kind of the terms of lawn, where lawn was built on profiles,
I was gonna
right? So yeah. So with that, do you think that one of the best ways to standardize is to actually have set profiles so that now, like let's say, outside air temp is always analog value 105 and occupancy is always, multi-state value 4, right? Like, and so that way it doesn't matter. Now vendors have to conform to that specific profile that they want to use for their application. What about something like that?
it should like this is, and that's to me we like as soon as Lon lost the battle between BACnet and LonWorks, like when Lon lost, like the interoperability push lost. Like we, and I think there's a number of reasons as to why Lon failed. I mean, everybody's going to point to the Echelon chip as the reason why it was proprietary, but I call bull BS on that one. I think it was really a manufacturer's push where they wanted to have their protocol the way they wanted to configure the protocol. They appreciated the opportunity that their solution wasn't fully interoperable with others as LawnWorks was. In theory, like I could take any manufacturer's LawnWorks controller and use anybody's configuration tool to set up a lawn network and to configure the device or program the device. Like that was ideally what we would want, especially like horizontally. I think where the other part that I think Lon struggled with was the vertical integration, like the LNS database. I feel provided opportunities where people broke the system more.
Yes.
And at some point, there was a push to be pure lawn, like a true lawn standard was open and interoperable, and they pushed against Tritium. And it's like, man, if we had LawnWorks and Tritium as more of that standard approach to buildings, I feel like we'd be further ahead with the interoperability piece.
You know that. I'm sorry. Go ahead.
I mean, that would
I didn't mean
that
to.
would then also we'd have better applications, we'd have better use cases, we'd have more of the iPhone Android scenario. Like we'd be much closer to that opportunity.
That's a hot. That is a hot take that you have, but actually, it's one that I also kind of share. Now, I hated lawn just for the neuron chip, and
Yeah.
not because of because of pricing, right? Like you had to pay to have it in there and whatnot. Though I think now if lawn goes more open source, like using things like having things on like GitHub and stuff like that. I think you're gonna see more of a push for it. But I actually agree with you that while backnet boasts interoperability, I don't know how interoperable it actually is, because I find that I can take any two lawn devices, and I mean any two lawn devices, and
Yeah.
I can put them on the same trunk, and they will talk all day long. They will speak the same language. And they'll play together. Like even if their own different sandboxes, they're tossing the ball to one another.
Yeah.
However, I find that building A or controller A doesn't necessarily talk to controller B and doesn't necessarily talk to controller C, even though that was one of the whole points of it, is to be truly interoperable.
Yeah.
And so I actually do agree that I think LAN is more interoperable than BACnet. And I know that there are some people that are going to hear this and they're going to be like, Charles, what in the hell are you talking about? I already know. I already know. There are going to be 5 people going to be in my inbox
Yep.
lighting me up on that conversation. But I argue with them that I can't tell you how many times from a back integration that I've had to do, where I'm like, oh, I can't get these two controllers to talk. Well, I guess I'm gonna have to put a ranter in here, and you're gonna go ahead and you're gonna play over there, and you're gonna shout across the way,
Yeah.
like using like the old, like when we, I don't know how old you are, but like in the olden days when we took cups and we had a string and we could go, we could go like 20 feet and try to whisper in the cup and see if we could hear the vibration from the string, right? Like
Yep.
I kind of feel that's kind of what they're doing, or more like Terrence and Phillip in one of the South Park episodes where they're floating away on the ice floe. It's like, I'm not your buddy, pal. I'm not your pal, friend. I'm not your friend, guy.
Yeah.
That kind of thing. So yeah, like I actually agree from an interoperable standpoint. I think LAN is better suited for it than Magnet is. It's just that people felt locked in
Yeah.
by the neuron ID and by the neuron chip. And I think that with the new push for more open source solutions, I think you're going to see LAN. I think you might see LAN make a comeback, though. From an edge perspective, right? If we go back to the edge perspective, where like we have like MQTT and REST API and other things like that.
Yeah.
I think that could be a different push as well. So
Yep.
I definitely want to have you back on the show to kind of talk more about that stuff, because I think you and I have similar things, but I think that we can expand on that more. But there was something that there's something you said earlier that I'm trying to remember. It's very clear that you've developed this strong philosophy of approaching projects and stuff like that. Um, and I think you mentioned about working backwards from the desired outcome. Can you, like, how has that principle guided your most successful initiatives?
This is so. I guess for me, it's always been focused on the user experience,
Okay.
and I tend to believe if we get that right, everything else falls into place. And by everything else, I mean energy savings, decarbonization, you know, right sizing your portfolio, like everything else falls into place. Like if if the user interaction is correct, everything else falls into line. That's kind of my starting principle. And an example of that would be the you know, and people would push back on me just based on the fact they're like, well, you don't have a touchscreen in your catalog, so this is why you make this argument. My argument was always, you'd have designers or engineers put in touchpads in a conference room on the wall, right? And like, why are you doing this? Well, it allows the person to like select their lighting scene or do this or that, and it's like, but why? Well, like if they're going to have a teleconference or they're going to do this, like, but nobody cares. Like nobody cares what the light levels are. Nobody cares. Like they just want to walk into the room and either lights come on automatically, or from an energy savings perspective, you flip, slap the switch on the side of the wall as you walk in the room and the lights come on, right? Like nobody wants to like bend over, read a screen, try to figure out what you mean with your, 10 character word for each set point or each setting, right? Nobody wants to try to figure this out and look at the screen, right? You literally want to walk in the room, hit a switch, lights are on. Like the cameras don't care anymore. Your LCD screens don't care anymore. Like nothing in the room cares like what the light levels are, or if you have certain accent lights on or off, or blinds are open or not. Like it's all about simplicity and the regular way people interact with stuff. Like we don't have to change that, right? We just want to, enable it to do more things, right? So as long as that user experience is the way people would naturally tend to gravitate to doing something, we can then layer in other stuff, right? So then that switch to the person using it is just a regular light switch, but in reality, it's a momentary contact, which can then, depend on the time of day, react differently to the command, right? Like we're able to take something that is a very simple user interface and then add complexity behind the scenes to deliver various outcomes that are more intuitive and add value to the occupant in the space. The last thing we want to do is change their experience. The last thing you want to do is somebody have to pull out their phone, open an app, log in, and then change a set point, right? Like that is just the most cumbersome, challenging thing. You want the person to have the option if they want to, but that shouldn't be like, you shouldn't be changing the way people interact with the built environment to that degree.
So
Like the elevator control system. Like this is something where I don't know what to decide on this, because like the is it digital dispatch? I forget where.
yeah, that sounds all right.
I hate those systems. They are horrible from a society's standard way of interacting with people in an elevator bay, right? Like it's so awkward when you go into an elevator, you see somebody coming into the elevator bay and you're not there to hold the door open for them, right? Like it just feels like I'm being rude, I'm being disrespectful, like I'm no longer a participant in society. Like I don't care that you're in a hurry to a meeting, like I'm just gonna let the door close in your face, right? Like it's so uncomfortable, it's not natural. To be like, no, you have to press the keypad outside the elevator bay so the elevator knows where you're going. Like it's just so awkward, but it works so well. Like it saves so much energy. It makes elevator trips so much faster. And you're like, oh, I guess we got to get used to this one because it actually works. But like it's changed the way that we have to like interact with the building, and it's uncomfortable. Like so many people still struggle with this idea. Like I don't know how many times I walk in there, I press the floor I'm going to, and 9 times out of 10 I forget to look what elevator I'm supposed to go into. I guess I'm too old. Like what you were asking how old I was. I'll tell you, like I'm too old to learn new tricks, I guess. But
Well, that something like that, I think was, I think is interesting, yeah, about the elevator perspective. I was a speaker at ControlsCon,
yeah,
and so we went downtown Detroit, we were staying downtown Detroit, but the pre-con was actually in a different building altogether, and I was a fairly large building. However, trying to figure out what specific, like the elevators had letters, and so you needed to take a specific elevator to to that specific area of the building,
yeah,
and I'm like, but why? Why can't they all, like? Why can't I just get off the floor and maybe, okay, if I need to walk a little bit, down to the area, I will. Like that part's fine. Like why can't they all get me? So like when you said about why, in my head, I envisioned you having that same meme that we were just talking about,
yeah,
but literally on the text of the curtain that's draped over the table. But why? Like that really, instead of changing my mind, just but why? Um, and so, you hit something a little bit about kind of visualization. And I think I know where you stand. Where do you stand on the subject of graphics and user interfaces with built?
just get rid of them. I feel that there's so much time and effort wasted into trying to create graphics that could be spent writing your fault detection diagnostic code in your controller. that would actually create value for the end user. Like, I don't know. I struggle with this one because I used to be a proponent for the sexy graphics, and I think it's just the thing that, like, if somebody's buying and building automation system, it's like, what are you selling the person, right? You're selling them automation and convenience, and um, you're selling them something that ideally they'll never know exists, right? Like, if it works well, they don't know it's there. Um, so what do? You create sexy graphics to show them that it's working well. And that's easy to put on a marketing page. It's easy to talk through from a sales pitch. It's easy to show, oh, look, if you hover your mouse over this, you're going to get contextual information about what's going on there. But in reality, like, we don't need it. Like, if, and this goes back to the if the system was designed properly, if the system was programmed properly, if the system was commissioned properly, nobody ever needs to look at that screen again. We're in a space where historically, like, in a 1950s automobile, like, I would need to keep an eye on my oil pressure. I need to keep an eye on my voltage. I'd have to keep an eye on my RPMs. I'd have to keep an eye on these things because we didn't have something in the car doing it for me. But now I don't care. I don't care what my oil pressure is. Like, I really don't care what my RPMs are either. Like, it just doesn't matter anymore. So, like, the RPM, the tachometer on a car today is just there to appease that that whole sense of, like, that driver sense, like the appeal to the driver. That's like, you know, you're seeing the RPMs rev up on the engine, right? Like,
Yeah.
it doesn't do anything. Like, I'm not like, oh yeah, wow. Like, usually I'm 6,500 RPM or 65. That's a lot, but like, I'm usually 2,700 RPM at 80 miles an hour. Why am I at 28? I'm not doing this analysis. Like, so I just think it's a distraction. I think it's a sales pitch. I think it doesn't add truly much value unless somebody's really trying to diagnose something. But on a day-to-day basis, like, for your like for your interaction with the system, doesn't add value.
Yeah, admittedly, I hate graphics myself for a multitude of reasons. One is that you know, obviously, I have to teach graphics, and I am working something on the partner conference that I'm going to be uh, uh, talking. I have quite a few presentations to do there, but one thing I do talk about is kind of um, some people want to learn how to do better graphics, and so I'm going to show them some additional things. But admittedly, I actually hate graphics as a whole myself, and I tell people all the time, like, if your building is running flawlessly, then people aren't going to look. But if there's something there for people to look at, and all of a sudden it's horrible, then they think the system is horrible. Even if even if the building is running like a well-oiled machine.
Yeah.
Um,
Or it makes them want to tinker.
yep.
I mean, it's one thing, like, and I'm not trying to suggest that the building operators are not educated. Like, that's not what I'm saying. But, like, there's one thing when, like, you need to know what's going on versus, like, what's happening within a VAV box or air handling unit or chiller, right? Like, in some aspects, like, systems may be complicated or large enough or whatever, where you have people who are at the level of which they understand the nuances of all those different data points, and the visualizations add value, right? But, like, for most day-to-day situations, I just don't see the need. I just feel like it introduces more opportunity for error than it can resolve. Like, it's just a better use of time would be creating the check engine light scenario, so that, when that light goes on, you call your mechanic and have them come fix it.
No, agree. I absolutely agree with that sentiment. I think that you've brought some unique perspectives to this conversation, and I think that especially some of the users or some of the audience that's going to be listening to this, I think it's definitely going to open some of their mind on certain things, and I think that there are quite a few talking points, and like I said, I know I'm going to catch hell for the lawn, especially because at times I hated lawn, but that's a whole that's a whole other off topic
I
conversation. But
know.
yeah, I'm gonna get some people. I believe in law and order when it comes to wiring, and since lawn is free topology,
Mm.
um, people are like, oh, I can wire this however I want and it'll still talk. And I'm like, why? Right? Like you, when your thing was like visualization, you're like, well, why? I'm like, well, why would you do that? Like, why wouldn't you just go from one device to the other, to the other, to the other, and now we can trace it and go back. But when people do that kind of hodgepodge. But anyway, Brian, thank you so much for being on the show. You really have been an awesome guest, and I really would like to have you back because I think that now talking a little more, I think I've got some additional things that we could hit on, and I think that you'd be a really good a guest to have on there. So, Brian, I really do thank you for taking the time out of your busy day to come on to the show and share your knowledge.
I greatly enjoyed it, and I appreciate the opportunity. And as long as we keep getting people angry and upset and asking the question, "What are you thinking?" or like, "Why are you saying these things?" Like, I think we should keep talking. Like, because as long as we're asking the questions on why we're doing certain things or challenging the status quo, like, it's getting people to think differently about what we're trying to accomplish.
Well, that's all we have for this episode. Remember to stay curious and don't forget to ask, but why? Until next time, I'm Charles.
And I'm Matthew.
And this has been It's a Controls Problem.
Please delete the good question and response. I hate that comment. It's just me buying time.